And it's mostly about the bandwidth, the speed of the connection between your brain and the digital extension of yourself. Particularly output. And output, if anything, is getting worse. You know, we used to have like keyboards that we'd use a lot. Now we do most of our input through our thumbs on a phone. And that's just very slow. A computer can communicate at 1 trillion bits per second, but your thumb can maybe do, I don't know, 10 bits per second or 100 if you're being generous. So some high bandwidth interface to the brain, I think, will be something that helps achieve a symbiosis between human and machine intelligence, and maybe solves the control problem and the usefulness problem. Well, I think about what technology solution is necessary in order to achieve the particular goal, and then try to make as much progress in that direction as possible. So in the case of spaceflight, the critical breakthrough that's necessary in spaceflight is rapid and complete reusability of rockets, just as we have for aircraft. You can imagine that if an aircraft was single use, almost no one would fly. Because you can buy, like, say, a 747 might be $250 million, $300 million, or something like that. You'd need 2 of them for a round trip. But nobody's going to pay millions of dollars per ticket to fly, to do air travel. But because you can reuse the aircraft tens of thousands of times, the air travel becomes much more affordable. And the same is true of rockets. So our rocket costs $60 million roughly. So the capital cost, if it can be used once, is $60 million. But if the capital cost, if it can be used 1,000 times, is $60,000. So then if you can carry a lot of people per flight, then you can get the cost of space flight to be something not far from the cost of air flight. So it's extremely fundamental. Because Earth's gravity well is quite deep, Earth has a relatively, fairly high gravity, the difficulty of making a rocket reusable is much greater than the difficulty of making an aircraft reusable. And that's why a fully reusable rocket has never been developed thus far. But if you use the most advanced materials, most advanced design techniques, and you get everything just right, then I'm confident that you can do a fully reusable rocket. Fortunately, if Earth's gravity was even 10% stronger, I would say it would be impossible. Well, I suppose honestly that it tends to be gut feel more than anything else. So when I interview somebody, my interview question is always the same. It's
what do you ask?
I said, tell me the story of your life, and the decisions that you made along the way and why you made them. And then, and also tell me about some of the most difficult problems you worked on and how you solved them. And that question, I think, is very important, because the people that really solved the problem, they know exactly how they solved it. They know the little details. And the people that pretended to solve the problem, they can maybe go one level and then they get stuck. Biggest challenge in life?
No challenge.
Well, no, there's a lot of them. I'm trying to decide which is which is the worst. I think just thinking about how to spend time. One of the biggest challenges, I think, is making sure you have a corrective feedback loop, and then maintaining that corrective feedback loop over time, even when people want to tell you exactly what you want to hear. You know, I think advice, I mean, if you want to make progress in things, I think that the best analytical framework for understanding the future is physics. I'd recommend studying the thinking process around physics, like not the equations. I mean, the equations certainly they're helpful, but the way of thinking in physics is it's the best framework for understanding things that are counterintuitive, and you know, always taking the position that you are to some degree wrong, and your goal is to be less wrong over time. One of the biggest mistakes people generally make, and I'm guilty of it too, is wishful thinking. You know, like you want something to be true, even if it isn't true, and so you ignore the things that you ignore the real truth because of what you want to be true. This is a very difficult trap to avoid, and like I said, it's certainly one that I find myself in having problems with. But if you just take that approach of you're always to some degree wrong, and your goal is to be less wrong, and solicit critical feedback, particularly from friends. Like friends, particularly friends, if somebody loves you, they want the best for you. They don't want to tell you the bad things. So you have to ask them, you know, and say, really, I really do want to know. and then they'll tell you.
Well, it is actually quite difficult to get all the permits, and it requires a lot of effort and a lot of cooperation with the authorities. So I would definitely not say that it is easy to get the permits. It's not easy. One of the approaches that we did take was to proceed at risk with temporary permits. So there is a way to accelerate things in the system to go with temporary permits, but the risk is that your long-term permit could be denied, in which case that you have to stop everything. The temporary permit and then the risk of having to stop and tear down. I don't know. I mean, frankly, I think there's probably a lot of risk associated with Tesla, and if a low-risk situation is what an investor wants, I would recommend not investing in Tesla. Well, I think the speed is a fundamental determinant of the competitiveness of any company. So, especially when there's technology involved. So, the rate of innovation fundamentally determines which companies succeed. You know, which companies are the number one in a particular arena. If one company has twice the speed of innovation of another, provided that company does not die of a self-inflicted wound or die have infant mortality, the company with the high rate of innovation will unequivocally win long term. Yes, clearly, like I very much think that, and I've said this many times, the making of a prototype is easy, but production is hard, especially if you have advanced production techniques that people have not used before. The vast majority of our engineering effort is in manufacturing, basically designing the machine that makes the machine. So I can't emphasize this enough. The factory, especially in advanced factories, the hard part. The vehicle design is comparatively easy. So we will aim for 500,000 vehicles a year. That is our goal, to get there as quickly as possible. The only limitation on growth is how quickly can we make cars that are high quality, high reliability. That's the only governing element on the rate of progress. But nonetheless, even with extreme effort, I think it probably takes us until, this is just a guess, until roughly the end of 22 to reach that level of production. If you have a compelling product and and it is affordable, so the value for money is good, affordability, you know, people can have enough money to buy it, and the product itself is compelling, then demand is never going to be an issue. So that is not something I worry about. I do worry about making sure that we can achieve affordability thresholds, because even if you make the value for money infinite, if people do not have enough money to buy it, they still can't. And then it's just frustrating for people. They see this great product, too expensive, can't buy it. So.